Somebody on your sales team asks the company AI assistant a simple question. What's our refund window for enterprise customers? It answers in 2 seconds. 30 days from the invoice date with a written request to support. Confident, specific, formatted like it came straight out of the contract. It did come out of the contract. That's the part worth sitting with. The system found the right document. It opened your enterprise master agreement, pulled a passage about refunds, and reported what that passage said. The passage it pulled was the standard tier clause on page 9. The enterprise terms were amended in March. They sit on page 34, and the window there is 14 days. Right document, wrong 3 paragraphs. And nothing in the answer tells you which 3 paragraphs it read. This is the failure that happens to the companies that did retrieval properly. The model didn't make anything up. That was the last episode, but this system retrieved something real, something relevant, and something wrong. Those 3 things are allowed to be true at the same time, and why they are is the whole of this episode. To see how that happens, you need one idea, and it's the only technical thing here. In the episode on RAG, we established that the system searches your documents before it answers. I left out how it searches. It isn't looking for words. If it were, you'd have a much more obvious problem. You ask about the refund window, your contract says reimbursement period, and you get nothing at all. So instead, the system converts meaning into position. Picture every paragraph your company owns placed somewhere in a very large space. Paragraphs about similar things sit near each other. Paragraphs about unrelated things sit far apart. Refund terms cluster in one region, security policies in another, expense rules in a third. The address of a paragraph in that space is a long list of numbers, a few hundred of them, sometimes a few thousand. That list is called an embedding. The store that holds all of them is a vector database. Your question gets converted the same way. It becomes a point in the same space. The system looks around that point and returns whatever's nearest. That's semantic search, and it's why these systems feel so much smarter than the search box on your intranet. You ask in your words, and it finds the paragraph written in the document's words. Now, the sentence that costs companies money, the system returns what's nearest. Nearest is not the same as correct. Distance in that space measures resemblance. It doesn't measure whether a passage is current, whether it applies to this customer, whether it was superseded last quarter, or whether it's the approved version rather than somebody's draft. Those aren't features that got left out of the product. They're not the kind of thing the measurement can see. That produces 4 distinct failures. They have different causes and different fixes, and only one of them looks like a failure when you read the output. 1, the answer got cut in half. Your documents don't go into the system whole. They're sliced into pieces of a few hundred words, chunks, because you don't want to hand the model an 80-page agreement to answer one question. The slicing happens at a size, not at a meaning. So the clause stating the refund window lands in one chunk, and the exception that changes it for enterprise customers lands in the next one. The system retrieves the chunk that best matches the question. It has no way to know that the sentence qualifying it sits 40 words further down, in a piece it didn't take. What you get is a true statement about the document and a false statement about your situation. Two passages mean nearly the same thing and do completely different things. Employees receive 20 days of paid leave. Employees receive up to 20 days of paid leave, one word apart. In that space of meaning, they sit almost on top of each other. In a dispute, they aren't remotely the same sentence, and a person reading both would stop at the second one. The pattern runs through everything a business writes. Standard terms and enterprise terms, the policy and the exception to the policy, what we do and what we do unless. Those pairs are written to look alike because they're about the same subject as C, and looking alike is exactly what the system is measuring. 3. It has no sense of time. Somewhere in your systems there are 3 versions of the same document. The original policy, the revision, and the one that's actually in force. All 3 cover the same subject in nearly the same language, so all 3 sit in the same region of that space. Nothing about a document's position says which one is live. Recency isn't a direction you can travel in, unless somebody tagged those documents and taught the system to prefer the newest, which is a build decision, not a default. The old version can win, and it'll win consistently, not occasionally. That's worth pausing on because it's counterintuitive. These errors aren't random. The same question pulls the same wrong chunk every time for everybody until somebody happens to check. 4. It never comes back empty. This is the one that turns the other 3 into a business problem. Ask about something your documents genuinely don't cover. a rule that was never written down, a question that belongs to a different department. The system doesn't return nothing. It's built to return the closest matches, so it returns the closest matches. If the closest thing in your entire library is 40% relevant, that's what comes back. Then the model does the thing it's best at. It reads three loosely related paragraphs and writes a confident, well-organized answer out of them. No error, no warning, no flag on the screen. The answer to a question you have documentation for, and the answer to a question you don't look identical. So here's the objection. You tested this, it answered 50 questions, it got them right, and people were impressed. Two things about that test. The questions were almost certainly written by people who knew the documents. When you know the source, you ask in the source's vocabulary without noticing you're doing it. You say reimbursement period because that's the phrase you read an hour ago. Retrieval performs beautifully under those conditions, and it should. You handed it a question written backward from the answer. Your actual users have never opened the document. They ask about the thing they need, in the words they'd use with a colleague, and they leave out the detail that would have selected the right clause. The second thing is size. A pilot loads 50 documents, and 50 documents about different subjects are easy to tell apart. Production loads 50,000, and a large share of those are versions, templates, regional variants, and drafts of each other. The difficulty doesn't scale with how many documents you have. It scales with how many of them are nearly the same. All four of these are fixable. None of them is fixed by the part that got quoted. Fixing them is work underneath the demo. Chunking that follows the structure of a document instead of a word count. Metadata on every document saying what it is, which entity it applies to, and when it took effect. A second pass that rereads the top results and reorders them. Rules about which sources outrank which. And it means the thing almost nobody buys, an evaluation set. A few hundred real questions with the correct passage recorded next to each one so that when somebody changes a setting, you can measure whether retrieval got better or worse. Without that, you aren't tuning the system. You're adjusting it and hoping, and every adjustment moves the results for questions nobody is looking at. So here's what to do with all of this. 3 things to ask for and 1 test you can run yourself. 1. Ask to see the passages, not just the answer. Every answer should show which chunks it came from which document, at which version. If the interface can't show you that, then nobody in your company can check the system's work, including the people who built it. 2. Ask what happens when nothing matches well. There should be a flaw, a score below which the system says it doesn't know instead of assembling something. Ask what that threshold is, and ask to watch it fire. A system that has never once said, "I don't have that," isn't a system that's never been asked. 3. Ask how a document gets removed. Superseded contracts, retired policies, the deck from the project that got cancelled. If nobody owns deletion, your index only ever grows, and everything I've just described gets worse in a straight line. Then the test, and it costs you an afternoon. Take 20 real questions from people who've never read the source documents. Support tickets, sales emails, whatever's already in somebody's inbox. Run them. For each answer, open the document yourself and check which passage it used, not whether the answer sounded right, whether the paragraph was the correct paragraph. That number is the only performance figure that matters here, and for most companies, it's the first time anyone has measured it. 20 questions is enough to tell you whether you have a system or a demo. Back to the refund window. Notice what went right. The document was in the system and it was the correct document. Retrieval worked. The model invented nothing. Every component did the job it was built to do. The answer was still wrong, and wrong in the hardest way to catch. Plausible, sourced, and specific. That's the thing to take from this whole layer. Embeddings gave software something it genuinely never had, the ability to find things by what they mean rather than what they say. Most of what feels intelligent about enterprise AI is standing on that. But what it finds is what resembles your question. Whether that passage is current, whether it applies to you, whether it's the version actually in force, none of that is in the measurement. All of it has to be built on top by somebody, deliberately. Similar is not the same as correct. Every retrieval failure you will ever meet is a version of that one sentence. So when somebody demonstrates an AI that searches your company's knowledge, the question isn't whether it found something. It will always find something. The question is, how would we know if it found the wrong thing? Next time, the 5 questions to ask before you approve any AI project. One page, and you can take it into the meeting. If this was useful, subscribe. See you then.